Alright, this is going to be geometric sequences, the second video. If you haven't seen the basics video, I suggest you watch that before this one. So my first example, he'll write a rule for the nth term of the sequence, and they give me A3 is 27 and R is 3. Now, I know the title says geometric sequences, but let's assume we didn't know. So this is like a question on a quiz or a test. And it just said write a rule for the nth term of the sequence. Well, right now, I don't know if I'm supposed to be using the arithmetic sequence formula or the geometric. So let's figure out how we can maybe identify that. Well, you actually know by what they give you. So they give you A3 equals 27, and they tell you R is 3. If they're telling you what R is a ratio that always and only deals with a geometric sequence. So I know I'm dealing with AN equals A1 times R raised to the n minus 1. So because of R, that's how I knew it was geometric. If that was D there, I would have known it is arithmetic. So when dealing with geometric sequences, there's two pieces we need to write our rule. We need to know the first term, and we need to know R. Well, looking at what we have, they actually gave us R, so this piece is good to go. So we have to somehow figure out A1, our first term. So here's what I'm going to do. I'm going to plug in what we do know. We did know R is 3. So looking at my formula, I'd have AN equals A1 times 3 raised to the n minus 1 power. Alright, so I use that piece. Great. I still don't know what A1 is. I don't know what to do with this, so maybe let's use this other piece. So I have A3 equals 27. Notice the subscript of 3 is in the same place of n. So they just told us, hey, let's make n 3. So I'm going to replace all of my n's in this line with 3. So now I know A3 equals A1 times 3 minus 1 in the exponent. But there's one more thing we know there. We know what A3 is. We know A3 is 27. So instead of writing A3 here, let me write 27. So I have 27 equals A1 times 3 raised to the 3 minus 1 power. Now let's clean this up and see if we can solve for A1. So if I'm trying to solve for A1, I got to clean up this right side. We'll have 3 raised to 3 minus 1. What you can do is, if you're not, you want to get this done quick, use a calculator. Type in 3 raised to 3 minus 1, and boom, you get 9. Or you could just think in your head, well, 3 minus 1 is 2, so 3 squared is 9. So I have A1 times 9. Well, again, I'm trying to solve for A1, so what I'm going to do, divide by 9, and now I know A1 is 3. So now I know R, now I know A1, so I have both my pieces so I can write the rule. So I'm going to have AN equals, well, A1 is 3, times R, which, hey, that's also 3, raised to the n minus 1. This is my rule. A quick note on this, by the way, don't multiply those two. The reason you can't multiply those two is because of the exponents. We have 3 times 3 raised to the n minus 1. That is our rule. All right, well, let's move to the second example here. We have to write a rule for the nth term of the geometric sequence. So this problem, they told us right away, hey, you are dealing with a geometric sequence. So they kind of gave us that knowledge. So now I know I'm dealing with AN equals A1 times R raised to the n minus 1. So I got to figure out, how do I use this information? Do I have A1 or do I have R? Well, they gave me A2 is 28 and A5 is 1792. So they did not give us A1, they did not give us R. But we can use this information. For example, over here they tell us A2 equals 28. Well, notice the 2 is in place of the n. So if I replace all the n's there, I'm going to have A2 equals A1 times R to the 2 minus 1 power. But I also know A2 is 28. So I have 28 equals A1 times, I'm going to clean up this because 2 minus 1 is 1, or r to the first power. Well, I use this left piece. I'm going to do the exact same process, but with this right piece. So I'm going to know A5 is A1 times r to the 5 minus 1. I just replaced n there. Replaced both my n's with 5 because I know n is 5 there. Well, A the fifth is 1792 equals A1 times R. 5 minus 1 is 4. So my goal is to figure out what A1 is or figure out what R is. That is my goal. Well, over here, if I wanted to solve for A1, I would divide by R. I want to get R by itself. Divide by R. Well, what happens there when you have an R on top and bottom? Those are divided out, so I know 28 over R is A1. Well, why can that help us? Well, I know A1 is the same as 28 over R. So let's take this and plug it in right there. So let's see what happens here. We have 1792. We have a system here of two equations. We're solving by substitution. It might not look like that since there's not x's and y's there, but we are solving by substitution. We have 1792 equals, instead of A1, 28 over R times R to the fourth. Well, the reason this works out nice is if you multiply the top and the bottom, we have 1792 equals 28R to the fourth over R. We have 4 R's on top, 1 on bottom, so if you simplified this, take away 1 from each, I now have 3 up there. Now I'm running out of room. 1792 equals 28R to the third. Well, if you divide both of those by 28, we have 64 equals R to the third. You can actually solve that for R. If you want to get rid of the third power, what you're going to do is take both sides to the 1/3 power. So 64, it's hard to see there because of the glare. 64 to the 1/3 power. And we get R is 4. So I have one of my pieces. What I need to do is I need to find my other piece. So once you know R, you want to plug back in to find A1. So what I'm going to do is I'm going to plug in over here. So I had 28 equals A1 times R. But I know R is 4. So that's what I did. I took my R, plugged in for A1 over here. Divide by 4, and we now know A1 is 7. So I have A1 is 7, I know R is 4, so I could put it all together using my geometric sequence formula. So I'm going to have AN equals 7 times 4 raised to the n minus 1 power. And that is my rule. Again, do not multiply those because of that exponent. And that is geometric sequences 2.